Pearson, DriveRight, 11th edition, Chapter 9, Lesson 9.4, Stopping Distance. When you have to stop quickly, you must do three things. You must perceive the hazard in your path of travel, react, and brake to a safe stop. Total stopping distance. The distance your car travels from the time you first perceive a hazard until you reach a full stop is your total stopping distance. You should always be able to stop within the distance you can see ahead. Refer to Figure 8 as you read how the time required to perform each of the three actions determines total stopping distance. Notice that it will take you almost 300 feet, or the length of a football field, to stop if you were traveling at 65 miles per hour. Perception, time, and distance. The length of time it takes you to identify a hazard, predict a conflict, and decide to brake is your perception time. Perception time for alert drivers is about 3/4 of a second. The distance your vehicle travels during your perception time is your perception distance. Perception time varies greatly depending upon visibility of your alertness and your line of sight. Sometimes it takes longer to perceive a complex driving situation than to brake to stop. You can improve your perception time by using IPDE and knowing when and where to search for potential hazards. Always search at least 12 to 15 seconds ahead. Reaction time and distance. Once you identify a hazard, the length of time you take to apply the brake is your reaction time. An alert driver's reaction time is about 3/4 of a second. The distance your vehicle travels while you react is called your reaction distance. Braking distance. The distance your vehicle travels from the time you apply the brakes until you stop at your braking distance. In order to stop, your brakes must overcome your energy of motion. Braking distance is proportional to the square of your speed. If you were traveling at 40 miles per hour, your braking distance would be 4 times longer than if you were traveling at 20 miles per hour. Factors that affect braking distance. The most efficient way to stop is in a straight line. This allows the braking force to be distributed to all 4 tires, but many factors can increase the distance it takes to stop. Factors that can affect total braking distance include driver ability, speed, vehicle condition, roadway surface, hills, and the weight of the vehicle's load.